Good afternoon and welcome to our conversation with Narayan Menon. He is the CTO and EVP of Engineering at XCellAir, and he's one of the founders. This conversation today is part of our report on LTE Unlicensed, and we are talking about how to manage LTE unlicensed within a mobile network and how it can coexist with Wi-Fi. Najan, thanks a lot for taking the time to talk to us today.
And it's my pleasure, real pleasure to talk to you about these topics. Look forward to it.
Now, you're a new company, just announced. So this is all brand new. So I think it's good if you can give us a little bit of introduction and tell us what is that you do at XCellAir.
Absolutely. So at XCellAir, we are developing network management and optimization solutions for HEPNets, in particular for small cells, LTE, small cells, and Wi-Fi networks. The company was formally launched a few weeks ago. It's a spin-out of InterDigital, and folks like myself and the rest of the team were with InterDigital for several years. The technology was initially incubated and developed starting in late 2013 in InterDigital. And a few weeks back, the team and the technology was transitioned over to XCellAir, which was launched just before the Barcelona show. So the solution is management and optimization. So we cover things like provisioning, configuration management, fault management, optimization techniques like SON, applied to both Wi-Fi and cellular, and also other things, other optimization aspects like traffic management, capacity management, traffic steering, and things like that, as applied to both Wi-Fi and cellular. It's cloud-based, scalable, multi-vendor, multi-technology, etc. So that's a brief overview of what we are and what we're doing.
Well, that's quite interesting because it's brand new, but you have a lot of experience and a lot of work already done. So you start off in a very good position, and it's really a very hot topic right now because all operators are working both with Wi-Fi and cellular, and obviously they face a big challenge in how to combine the two. And to date, it's basically been a basic offload type of environment where whenever there is Wi-Fi, you use it, but there is not much in a way of planning and managing the two sources of traffic. And with LTE Unlicensed, it's going to be, so to say, a third layer of complexity, integration, and opportunity at the same time. So maybe why don't we get into the core of the things? How then LTE Unlicensed will fit in with both Wi-Fi on one end and licensed LTE on the other end?
Yeah, that's a very interesting question, Monica. LTE Unlicensed, the way we see it, is going to be a nice complement to LTE the way it is today, right? So it will help LTE systems, it'll help augment the capacity and bandwidth available to LTE systems by being able to take channels in the unlicensed band and aggregate them with channels in the licensed band, right? So it serves as basically a bandwidth boost for the LTE solutions. Now, a lot of the scenarios we're talking about here involve both the macro cells and the small cells. So it could be that there are several scenarios that people are starting to define, which include combinations of aggregation between small cells, between small cell clusters, between macro cell and small cell, etc. So it's the bandwidth boost aspect. It's also the ability to segregate traffic, place traffic intelligently on one or the other, licensed or unlicensed, based on quality of service requirements, etc. Wi-Fi, yes, Wi-Fi is a very key aspect to consider because when LTE operates in these bands, in the 5 gigahertz band, it will need to coexist with Wi-Fi, right? As well as coexist with other LTE systems that are operating the same band. So the channel access etiquette and following the etiquette and following the rules that apply within the band become very important, so that one doesn't trample on the other. The LTE system doesn't trample on or interfere with the Wi-Fi solutions. So the coexistence of the two systems, Wi-Fi and the LTE unlicensed, will become very, very critical. Yeah. So that's the kind of the way they would relate to each other. One would not necessarily displace the other. Wi-Fi will have its own place and continue to have its place in the sun. But what this enables is for the LTE solutions now to expand and reach out into the unlicensed spectrum and gain more bandwidth.
Yeah. So there are going to be locations where there is only Wi-Fi or LTE unlicensed, and that's relatively easier. The issue, the challenge for the operator is to manage those locations in which you have both Wi-Fi, LTE unlicensed, and LTE. So in terms of how you manage the different traffic flows, supposing you have the three interfaces, how can an operator, or how can you help an operator steer different types of traffic onto the different interfaces?
Again, a very, very interesting, very relevant question to this whole topic as well. Traffic steering, or the traffic segregation, as we call it, becomes a very good opportunity for the operator to do with this kind of scenario. And the way they could do it based on a couple of different parameters, right? It could be done based upon policy. So policy as it relates to the user's SLA, as it relates to the user's quality of service requirements, as it relates to the type of application using the system. So the policy could end up placing some types of applications on one system and some types of applications on the other system. So for example, applications that require a high level of quality of service and reliability, the operator might prefer to keep those on the license band, whereas best effort traffic, for example, might be placed on the unlicensed band. That's one mode of operation, right? Or it could be the other way around, depending on what the end scenario is. The operator could also leverage this to provide, wholesaling type operations, wholesaling type capabilities to MVNOs and third parties. So in some cases, the bandwidth that is wholesaled to the third party folks might come out of the unlicensed band, or it could be the other way around. They might prefer to place that on the licensed band. But what LTE gives the operator is that flexibility, to place one here, one there. The other angle towards that is network conditions, right? So it's policy as well as network conditions. So as conditions change, the system has to be adroit enough, nimble enough to be able to move things around. So if a particular application is on the unlicensed band and things start to get flaky because there's too much contention there, the system might move that piece of traffic back to the licensed band. So it's those kinds of mechanisms based on awareness of the network conditions, based on awareness of latency, throughput, packet loss rates, etc., have to come into play to make this work really well.
Yeah.
Yeah, go ahead.
And this is interesting because it's a level of complexity that it's difficult to manage, but if you manage it, it brings a lot of value to the operator because you can use the resources more efficiently. So you're basically combining the real-time component from the RAN. So the information from the RAN, real-time, feed it back with policy or whatever decision the operators might do in terms of how they want to manage traffic, and then combine the two. And is that correct?
That's exactly it. And then the third knob, which comes into play, is user preferences, right? So on top of all of this, the user might have certain preferences. For example, not to use the unlicensed band at all in certain scenarios or certain locations. So those could come into play as well, working within the bounds or the shaping that the policy does, right? We're working within those boundaries, I guess.
Yeah, and I think that this actually raises an important issue of the subscriber choice because some might worry that the operator might force them not to use Wi-Fi, for instance. And that's a reasonable concern, and you want to make sure that the subscriber has his or her own say in that.
Right.
Now, there are two questions in terms of the type of traffic. There is voice, which is a special case. And so how can an operator manage voice in this circumstance, in this case where you have the three different interfaces?
Again, voice would be treated as one of the applications, and it's obviously a very key application, right? And especially, as we move more and more towards voice over IP, away from the circuit switch world, the whole aspect of network quality and link quality and quality of service becomes more and more important. So in the case of voice, I think typically the default preference would be to perhaps keep that on the license side. But if you're using voice over IP, there's no reason why it couldn't be on either, right? But again, this would be susceptible to the actual network conditions. So if the voice call is on the unlicensed band and the conditions start to get bad, they would need to be able to hand that back over to the licensed band.
Yeah.
And that sort of capability becomes very important. So in a sense, voice over IP, video, and other applications. Each application could have a policy per user policy against it. So there would be a per user per application policy, which really depends on what the users signed up for, paid for, etc. And then based off that policy, the application might be placed in one place or the other. But then if things change, if conditions change, they will need to be moved back and forth. And if the user has some preferences applying on top of that, those preferences will need to be respected as well.
And the same flexibility can be used when an operator has to manage vertical applications, Internet of Things. When you have a different type of devices, very different requirements, and that's creates even new challenges there.
Absolutely, and when you get to Internet of Things itself is such a diverse world, right? There are tons and tons of applications in the IoT space itself. Some of them will require higher reliability. So, for instance, healthcare-related applications will require the reliability, right? You may want to keep those on the band which you consider to be more secure, more safe, right? So that perhaps belongs more on the license side. Whereas some applications within the IoT space that may be best effort or may be possible to do after hours, for example, those kinds of applications, you have more flexibility in terms of placing them on the unlicensed side.
Yeah. Now let's talk about the unlicensed part of this. Mobile operators today use unlicensed spectrum through Wi-Fi offload, but they don't really manage it. Now with LTE unlicensed, there is a new challenge because they have to manage traffic both in licensed and unlicensed. So it's not only just two channels or two technologies. Well, in this case, it's the same over-the-air technology, but they have to manage it differently. How do they do it? What are the main differences from your point of view?
Yeah, I think the management of mobile traffic with respect to LTE-U, it has to happen at two levels. At one level, there have to be mechanisms in place to make sure that the LTE system, when it operates in the unlicensed band, is following the rules and etiquette that apply on that channel, on that spectrum, just to ensure that they don't cause any kind of damage to Wi-Fi services. They should not be impacting the Wi-Fi services any more than another Wi-Fi system in the same band, shall we say? So that's where the listen before talk and those kinds of mechanisms come into play, right? The other angle is on top of that is the traffic steering, traffic management capability we talked about, right? And being able to place traffic intelligently on one or the other based on the various factors that we outlined previously, right? And that is there's a challenge there in terms of how effectively that gets done, but it's also a huge opportunity for the operator. So it's really two levels. One is fundamentally making sure that the mobile traffic is not impacting or impeding other types of traffic, incumbent traffic on the unlicensed band. And the second aspect is once you've conquered that, you now try to make the best use of that band, right? To put the right things in the right place, basically.
Yeah. Now let's go back a little bit, and we've been talking about LTE unlicensed as if, and obviously an operator should use it, but you can also argue since there is Wi-Fi is there available. Every handset has Wi-Fi. Why does an operator need LTE unlicensed, and what is it going to gain from it that Wi-Fi cannot deliver?
Yeah, that's a great question as well. Wi-Fi is there today. But as you mentioned earlier, it exists in a somewhat disparate fashion, right? So today, when you go home, the iPhone switches to Wi-Fi no matter what, right? There's no real control, just like you just said, Monica. There's no real management. There's no control of that, right? There's no ability to put certain types of traffic on Wi-Fi, certain types of traffic on cellular. Those elements are kind of missing now. Now the cellular standards have been working on solutions that work towards this, right? That try to foster more integration of these Wi-Fi networks into the cellular core, right? They haven't yet come into play on a large scale in the cellular network. LTE-U provides another, in fact, in some ways, an even more interesting and more tightly coupled way of integrating the two types of bands without without really forcing the integration of Wi-Fi with LTE, right? You're not trying to integrate here a Wi-Fi solution with LTE. It's a different approach where you're trying to make the LTE solution work in the Wi-Fi band. Right? So it's another way of tapping into or leveraging the unlicensed band without necessarily trying to, couple Wi-Fi with cellular or integrate Wi-Fi with cellular in a very tight fashion, right? So that's the opportunity, and to be able to use that to provide aggregation, bandwidth segregation, right? So it could be used either to segregate traffic, like we discussed before, or to aggregate bandwidth and provide more bandwidth to an application when it needs it, right? So when a single application needs more bandwidth, you reach out into the unlicensed band, grab a couple of channels, aggregate them, and you get this boost, right? And it ties in nicely with the LTE architecture. Some of these mechanisms like listen before talk and radio resource management schemes relating to this will get built into the LTE architecture, So it becomes a much more whole, holistic solution that is able to tap into the unlicensed band.
So there is, from an operator, there is a way to leverage unlicensed spectrum in a more efficient way. And that's good. Now, what about the Wi-Fi end? So, for instance, if an operator tries to go and deploy Wi-Fi license, let's say in a venue, in a stadium, or something like that, is the LTE license going to be nice enough to the existing Wi-Fi infrastructure there? Or should we worry about, because there are a lot of worries that it's going to create a lot of disruption in the Wi-Fi area. Do you think that challenge is being addressed right now?
That challenge is being addressed quite adequately, in my opinion. There was a study item that PTPP started a while back to study LTE and to study the impacts of that on the Wi-Fi band, and to come up with requirements and recommendations for what needs to be done to ensure that the LTE systems don't disrupt the Wi-Fi systems in place, right? And the end of that study item resulted in a technical report which outlines several recommendations. So one of those recommendations is, one of the key ones is listen before talk, right? So that's essentially making the LTE system kind of do a channel check, see if there's any activity on the channel, at least via energy sensing or energy detection on the channel before trying to access and use that channel. So it's essentially making LTE almost behave like Wi-Fi. That's kind of what Wi-Fi does with the collision detect, etc. In that band, right? So that is a key mechanism that has been recommended to ensure that LTE operation of that band does not affect or impact the Wi-Fi systems. But then there are other things as well. They have recommended the use of DFS, dynamic frequency selection, for example, to prevent interference with things like radar systems, which operate in the 5 gigahertz band in some countries. That's the key piece. One of the recommendations is discontinuous transmission, to ensure that you kind of don't stay in there and hog the channel and increase the probability of a collision due to a Wi-Fi system coming on and trying to access the channel. We have discussed things like radio resource management schemes that will come into play here. The other key angle here, since this is going to be a landscape where Wi-Fi and LTE systems have to coexist with each other, we believe that some of the SON schemes we have today have to evolve as well to incorporate this awareness of other systems. Because today SON solutions are LTE specific, right? Or in some cases, there's limited SON functionality in some Wi-Fi systems. But one technology is not cognizant of the other. So we believe SON has to evolve significantly as well to create this cross-technology awareness. And that's an area we can help. At XCellAir, our solutions have come at the whole network management angle with a multi-technology, access technology independence angle from the beginning. That's been designed to our solution. And to extend our SON schemes to provide this kind of multi-technology coordination in the unlicensed band would not be difficult at all for us to do.
Yeah, and actually, so let's talk a little bit about what is that it's special about what you do in terms of help. How do you help the operators deal with this challenge?
Absolutely. So we've got solution but big part of our solution is network management and optimization. So we provide the ability to configure, provision, fault manage small cells and Wi-Fi access points. But also we combine that with optimization capabilities, SON capabilities. So optimal channel allocation, for example, interference mitigation schemes. The nice thing is that these are all tied into one solution, where traditionally the network management piece and the SON piece tended to be disparate, tended to be uncoordinated. We combine these into one end-to-end solution. To that, we are adding other capabilities like traffic management, traffic steering, bandwidth management, etc., into one holistic solution. The idea being that we help the operator accelerate the rollout of small cell networks. Today, one of the impediments we believe for small cell network adoption is the fact that you don't have plug and play automated enough procedures to bring up these small cells quickly. Because if you want to bring these up in large numbers, you need much more automated procedures than what the macro cell network management procedures support today. And also to be able to manage these millions of units in a hands-free, zero-touch fashion. That's what we are enabling with part of our solution, trying to enable the operator to get the small cells up and running fast and be able to manage them easily and scale the network easily. And then adding other aspects like capacity management and bandwidth management on top of that to enable the operator to extract value out of the network. Right? So one aspect is acceleration of deployment. Another angle is easy management and then value extraction from the assets they've deployed. The solution, what makes it unique, is there's three key attributes that make it unique. One is the fact that it is access technology independent. So from the outset, we've designed it to be unified across LTE and Wi-Fi to begin with, and to that LTE can be easily added. And that's been a design aspect fundamentally from the beginning, that we have developed the system in a way that there's a ton of reusable components that enable us to go from Wi-Fi to LTE very quickly and enables us to support the two systems with a unified visual interface, with a common set of algorithmic tools, common set of database components, etc. And that's very unique because a lot of systems start with one and then try to move to the other and end up breaking a lot of concrete to do that. The second key aspect is multi-vendor. So one of the issues that operators will have with large-scale small cell deployments is that they will inherently end up going multi-vendor, right? And today, each vendor solution comes with its own native management capability, its own EMS. What we provide here is a multi-vendor solution that easily works across multiple vendors' access points. And the way we do it is that the vendor specificities are isolated or confined to a small part of our system. So large parts of our system that deal with the algorithms, that deal with the databases, the visual tools, etc., do not get impacted when we move to from one technology to the other or from one interface to the other. It makes us adapt to each vendor specification very, very quickly and flexibly. So that's number two. The other key piece is the scalability. So our solution runs on the cloud. It's virtualized today in the cloud. And what that does is that it makes the network management solution very, very scalable for the operator. So as opposed to buying big boxes, big controller boxes up front, the operator can deploy this and scale the solution very granularly as the network grows. As they add more access points, the resources on the cloud side, the processing resources, memory, storage, etc., can be scaled very gradually, very granularly. So the operator is able to scale as they grow, and they pay for resources as they scale. So that gives a lot of flexibility to the carrier.
Now, in closing, can you tell us a little bit what should we expect next from you guys? It's this is all, this is all new ground. So what's coming next?
Absolutely. So on one hand, we are trying to we are working very promisingly towards taking our technology, our product to market, right? So we're dialoguing with operators, we're dialoguing with vendors to integrate our solution with different vendor access points. So near term, our goal is to get the ecosystem dialogues going, get to the IoTs, get to the lab trials, field trials in the next few months, and get this to market very quickly, right? So that's very much on our near-term roadmap. Longer term, in terms of other things we do, other features we add, we talked about the capacity management, bandwidth management capabilities, but going beyond that, it's things like analytics. We collect a lot of information from the access points, and we collect, store, and analyze them within our system. Attributes, metrics that relate to network performance, subscriber data that we get from the access points. So all of that data can be analyzed and made available to the carrier, service provider, via either via well-defined APIs or via analytics capabilities that we would provide in the future. And then, of course, things like support of LTE, that's very much on the roadmap. Supporting community Wi-Fi networks, enabling coordinated management of community Wi-Fi networks. Those kinds of things are very much on our roadmap as well.
Well, it looks like you're going to be quite busy for quite some time. Well, Nayant, thank you so much for sharing your thoughts with us today. And this conversation was part of our report on the license that is available on the RCR Wireless News website and on the Sensafili website. Yes, thank you very much for your time today.
Thank you, Monica. It was a pleasure.